My name is Evangelia Moschopoulou, and I would like first to thank the organizer of this workshop for giving me the opportunity to join the celebration, even remotely from Greece, of Robert von Triele's birthday. I think that this workshop that gathers the leaders in the field of crystallography is a splendid way to honor Robert von Triele and to express our gratitude for his contributions to the field of crystallography. And the title of my very brief presentation, Unravelling the Structural Signatures of the Physics in Quantum Materials and the Key Role of the General Structural Analysis System, captures somehow my scientific path for almost 25 years now on determining the crystal structures of quantum systems. So I will, first of all, start with the early days when I started using GSAS, and it was there during these days that I first met Robert von Triele. It was during my postdoctoral appointment at Los Alamos National Lab, where I was working with Zach Fisk and Joe Thompson at the Condensed Matter Physics Group. And there we were growing single crystals and we were preparing materials which could have interest for their physical properties. I had many new compounds. To give you an idea, in the first 4 months of my postdoctoral appointment, I had almost 80 new compounds to investigate their structures, either determine it or solve it. And it was there that I was introduced and I heard for the first time about GSAS. Often during this time, since I had many questions about GSAS, I was visiting Robert von Triele and Alan Larson at the Lucian Center at Los Alamos National Lab, passing through all the security gates and so on. And we had many discussions about how to use GSAS and more generally about crystallography. And these discussions led me to a deep understanding of crystallography and of its key role on approaching the physics of these new materials. And many of those materials, under various forms, are still subject of investigations in many labs worldwide. So these materials are part of a broader class of compounds, which are now known as quantum materials. They exhibit electronic and magnetic properties that have non-trivial quantum mechanical origin, and they are interesting not only for their basic physics, but also for their potential applications in energy, information, and sensing technology, and even to address currently unmet biomedical challenges. Because of the coupling and competition that they exhibit between lattice charge, orbital, and spin degrees of freedom, these materials exhibit complex crystal structures and subtle structural phase transitions. So it is very important to understand and determine in detail their crystal structure in order to be able to control the physics, to understand the physics and control their physical properties towards specific applications. Obviously, for my research, myself and my collaborators, we are using large-scale facilities, synchrotrons, neutrons, sometimes combinations of these radiations, depending on the material and on the problem that we have to address. We collect data on both powders and single crystals, and often under complex sample environments. All these nice data, however, wouldn't be useful if it was not possible to use the appropriate software. And this software, I'm talking obviously for GSAS, that Robert von Triele developed, is as I said, the appropriate software to include data from all these probes and provides us the precise and accurate information on all the details of the crystal structures and of the structural phase transitions in our systems. Since these first days, obviously I worked on many different compounds, intermetallics, oxides, borides, etc. And I had also discussions with Robert von Triele during my stay at Brookhaven National Lab when I was working with Dave Cox, to whom I express also my gratitude for what I've learned from him. at the beamline X7A. All these data were analyzed by using GSAS, and the recent years GSAS-II. Finally, before closing, I would like to thank Robert and Brian for being always present and replying my questions. I guess you all have this similar experience, but what I would like is here to highlight is that they replied even questions, even if these questions were not about beamlines or about neutron instruments, but even when these questions were about single X-rays, conventional X-rays at lab diffractometers. So since I don't have much time, I wanted to really to close by wishing Robert happy birthday. Many thanks for GSAS and also for letting me share in your lab of crystallography. I wish you many healthy, happy, and productive years ahead. And I would like also to thank again the organizers of this great workshop. Many thanks.